Hi, Ben with Novelex Stereophonic. Thank you so much for coming by the channel. In today's video, I'm going to be comparing two Dynaco ST-70 amplifiers. This one I restored to the stock schematic using precision parts. This one I did a gut rebuild on and used an aftermarket board from a company called VTA. So this driver board features 12 AU7 tubes instead of the harder to find 7199. It also has individual bias adjustment, which is a huge advantage. So in the comparisons, we're going to be looking at both bench tests and listening tests. For the bench test, I'm going to test for frequency response, total harmonic distortion, and max clipping power. And then for the listening tests, I'm going to take these to a friend's house and get together with a group of guys. We're going to listen to both amplifiers and try to determine if we can hear a difference between them, and if so, which one do we like better? So if that sounds cool, stay tuned and we'll get started. I'm going to start with the bench testing portion of this comparison, but before we jump into that, I wanted to go over the differences between the two models. Both of these units started out as original Dynaco ST-70s, but I restored them to different specification. So the one on the left here has been updated with a VTA 12 AU7 board with individual bias adjustment. I've also installed a triode ultralinear switch. We'll be testing this in ultralinear mode so that we're comparing these apples to apples. I tried to keep as many things identical as possible so that there's a fair test. These multi-section capacitors are the same. They are both supplied by DynaKitParts.com. I use the same brand coupling caps. These are Illinois capacitor axial polypropylene. So they're different values depending on the circuit, but they're the same part, so we're using kind of the same coupling capacitors. The parts in this one, when I restored this using the original schematic, this board was actually gutted and I used new old stock carbon composition resistors that I had in my stash, and they were precision matched channel to channel. That's about all we can see from the top besides the vacuum tube. So during these tests, I'm going to be using my reference set of Mullard XF2s. So this is a strong match set that I've had for a while. This will be a nice way to compare them both on the bench and when we do listening tests, and then just a generic strong testing 5AR4. So I'll be using the same set of tubes amp to amp when we do these tests. Before we get started, let's flip these over and take a look at the insides. If we look at the bottom of these units, they're drastically different from one another. This one, in addition to having the VTA board, I also did a gut rebuild on. So I pulled everything out of this, got it down to the tube sockets, and rewired it from scratch. This choke was damaged, so I replaced it with one from DynaKitParts.com. On this one, it was a factory wired unit, so I wanted to keep it as original as possible. When it came to me, it was in non-working condition and had a little bit of modifications. Somebody added a power supply to put DC on the filaments, so I had to reverse that and take it back to normal. So now this is back to as stock as it gets, just wired up with modern components. If we look at this section here, this is the negative bias supply in the original design. That's not needed on the VTA design because the negative bias happens right on the driver board, and that's one of the advantages. It has those little blue trimmers that allow us to adjust the bias individually for each output tube. So the negative voltage DC is carried on this green wire along with the audio signal that feeds the EL34s. One of the things that freeing up that tag strip allowed me to do was do a mounting of red and black banana jacks. So what I did here is I used the original terminal tie strip to set up my 4, 8, and 16 ohm taps, and then added a little strip here to do the same thing on the other side. So right now it's configured for 8 ohm. If I wanted to run this on 4 ohm, I would have to desolder this wire and move it over to one of the other taps. But it just gives me the flexibility and convenience of having banana jacks, but not being tied to one single impedance if I ever switch speakers or something like that. On this one, I've just got some spade to banana adapters on the common and the 8 ohm tap, so both of these will be tested at 8 ohms. All right, let's get the bottom covers back on, and we'll start with this one. We'll get it biased up and then start the analysis. Okay, I've got the original design set up and I'm ready to set the bias. I just have to go to 1.56 volts on each side. So on the original design, you need to have fairly well-matched pairs for it to bias up properly. And somewhere around there is going to be good, and it'll probably drop down a little bit here as I raise this one. So it'll be a little bit of a dance. I'll go over on this. You can kind of see how these interact with one another. It's because it's pulling down the supply a little bit when you draw more current. I think that'll be close enough for our test, 1.56 volts. Okay, let's start out with some output power and total harmonic distortion testing. After setting up for distortion testing, I noticed that I had elevated distortion in one channel, and after swapping the output tubes from left channel to right channel, it followed. So I've got something going on with one of my prized mullards. So I'm going to switch to a modern reproduction set of mullards. These are Russian made, but I'm getting much more consistent distortion results channel to channel, so we're going to go with this set. So a little bit about the setup before we get started. On the distortion analyzer up here, I have the test signal, which is going to be a low distortion signal from the analyzer itself coming into the input of the ST-70. The output goes across the 8 ohm taps into my dummy load at the bench, which is monitored on the oscilloscope. And then the input of the distortion analyzer I have connected directly at the terminal posts on the back of the amplifier as well. So we're measuring right at the amp, not at the load, which gives us the lowest distortion for the testing. So let's start out with some THD+N testing. We're going to be looking at how the distortion characteristic of this amplifier looks at different test frequencies, and then ramp it up to full power and see how much power it actually makes before it starts to clip. Okay, so to start out, we're looking at the amplifier producing 1 watt across the 8 ohm dummy load. We're looking at the left and right channel on the scope here. I have the yellow and blue trace overlaid so that we get a little bit more room on the scope, but it's showing we have very good channel balance. The waveform at the top, the violet one, is the residual distortion for the left channel, and the green one is residual distortion for the right channel. So in the later tests, we'll see basically a visual representation on the scope that corresponds to the distortion measurement that we're getting here. So right now I'm feeding the amplifier 1 kilohertz, and we can see at 1 watt we have very low distortion, below 0.02% at 1 kilohertz. I'm doing 1 watt because that's kind of like a normal listening level. And another thing to note here, with this amplifier, with this set of tubes, it's taking 112 millivolts RMS to drive this to 1 watt. So we'll compare that to the other amplifier to see if they have the same input sensitivity. It's going to be important to try to maintain that in the listening test, because if one amplifier is much more sensitive, when we keep all other things equal, one amp might be louder than the other, and then everyone will perceive that one as probably sounding better because it's louder. So we'll try to control for that. All right, so while we're here, we'll look at a couple things. I'm going to shift this into the distortion mode, which allows us to look at the harmonics, and we can see that we have a little bit of second harmonic and a little bit of third harmonic, but not much of anything else, just such low distortion right now. Let's take the test frequency and go up to 20 kilohertz. And there are still some differences in these output tubes, so I've got a little bit of elevated distortion in the right channel, but we're still really low, above or below 0.2% on both channels. And then if we take it down to 20 hertz, it might be a little bit elevated here as well. And you can see just a little bit of phase shift. So when we look at the frequency response later, we might notice them being a little bit different in the lower range. But still, we're below 0.5%, which is excellent. So let's take it back to 1 kilohertz. I'm going to ramp it up to clipping. We'll see what kind of power this amplifier can make. So I'm just going to lower this so that we have a little bit more room on the scope. I'm going to take the amplitude and just slowly ramp up this signal. Let's see, over here. And this amp is supposed to produce 35 watts per channel. We'll see if it can do that with both channels driven. Okay, so here where these spikes are, we can see that that's clipping, and that corresponds to the flat spot on the top of the waveform. So if I take it down to eliminate both of those spikes, we're right at about 35 watts per channel. So this amplifier is producing what it's supposed to, and we're below 0.4%. So we're not even reaching 1% distortion at full rated power. Now I'm going to take this over to 20 kilohertz and we'll see what happens. Distortion up, but still not above 1%. And then let's check 20 hertz. It's going to have some trouble here. Actually, I'm going to stop this test. That test doing 20 kilohertz, or sorry, 20 hertz at that output power can damage the rectifier. So we'll stop there. I'm going back to 1 kilohertz, and we have a little bit more distortion here. I'm just going to shift this in, and we'll see where the harmonics are. Okay, for this next series of tests, we're going to be looking at frequency response. So to start, I'm using my other oscillator. This one is extremely flat and it's great for sweeps, and it can also generate squares. So the first thing we're going to do is take a look at a square wave. And a square wave tells you a lot about frequency response. So just looking at this, I can tell this is going to be a very flat amplifier. The only issue I see is that there's high frequency rings, so there's a little bit of a ring on the leading edge of the square wave there. It's just a hair of a tilt downwards, but this is going to have extremely good frequency response. So let's go back to a sine wave, and I'm going to use the analyzer here as a dB reference. So we're going to measure AC. We're going to set a reference level here at 1 kilohertz of 0 dB. And now as we sweep the frequency, this is going to tell us how much it deviates from that reference level. So you'll be able to see the sine wave kind of shrink and expand, and we'll be able to see the numbers here. So I'm going to start sweeping it up 1 kilohertz at a time, and you can see the frequency on the analyzer there. So we're at 3 kilohertz, and I'm just going to continue raising it. And you can see we're not budging off of 0 dB, just a little bit here at 10 kilohertz, and we're staying fairly flat in amplitude there. So as I continue to rise, we've got a little bit in the right channel. It's a little bit ahead of the other one, but we're already at the human range of hearing here. 20 kilohertz, and we're at 0.08 dB out from reference level. So let's see where the negative 3 dB point is, because we'll notate this and compare it to the other amplifier. So now it's starting to roll off. We can see this shrinking here. And let's see, this channel just got to negative 3 dB, and we're at about 55 kilohertz. Let's take it the other direction. We can go back to 1K, and then I'm going to take it down 100 hertz at a time. So we're now at 500 hertz. We continue going down. There's 100. Adjust this so that we can see this a little bit better. Now I'm going down 10 kilohertz, or 10 hertz at a time. And this amplifier is extremely flat in the low frequency range. I'm at 10 hertz. We can start to see a little bit of phase shift here, and we saw that as well in the test when we were doing 20 hertz with the distortion. So you can see the waveforms are just slightly phase shifted, but I'm at 9 hertz now, and it's still not dropping. This is an extremely flat tube amplifier. So really, really great frequency response. Let's go back to 1K. So that's kind of most of the information that we need to know about this amplifier. How much power it makes at clipping, what the frequency response looks like. If we were to plot this, it would be almost a flat line out to around 25 or 30 kilohertz, and then it would start to slowly roll off. And then it'd be almost flat all the way down to DC, which is pretty surprising. So very, very flat testing amplifier, makes output power, has distortion below 1%, which is good to see on a tube amp. So let's set up the other amplifier and see what it can do. Okay, here's the VTA version, and I've swapped all the tubes over. This has been warming up for about 10 minutes, and I just need to set the final bias. So on this amplifier, we're aiming for 40 milliamps per tube, and there's a 10 ohm sense resistor, so we want 0.4 ohms on each tube. And I've opted to install these convenient test points that are also offered on the site where you can get the VTA boards. So right now, I just need to get each one of these to around 0.4. So right now I'm working on the front 2 tubes, and then when I change to these 2 test points, it'll go to the back 2 tubes. That's the way that I've wired mine. So I'm a little bit low over here. And just like we saw before, these adjustments are going to affect one another. So you kind of need to do the dance again to get everything right where it needs to be. I think that's close enough for me, so we'll get going with that. Okay, so I'm going to try to duplicate all of these tests on the VTA amplifier. So starting out at 1 kilohertz, the distortion is slightly higher than with the stock design. We were at about 0.02% at this same test frequency, but that doesn't give us the whole picture. So let's try 20 kilohertz. And we're at about 0.13. We were between 0.08 and 0.16 on the other amplifier, so they're pretty similar here. Let's go to 20 hertz. and it looks like we're seeing a little bit more distortion on the right channel here. And we've also got a little bit of phase shift, which we noticed on the other. So this could be just discrepancies in the output tubes that are tracking one amp to the other. This amplifier is performing kind of the same. So really, so far they're about the same, but I think the harmonic profile might be different. The distortion looks slightly different than the other amplifier, if I remember correctly. Let's check out the harmonic profile. Yeah, so we have a little bit more distortion, more second harmonic than third harmonic. So this is a little bit of a different harmonic signature than what the other amplifier has. Okay, and next up we're going to ramp this up to rated power and see where it clips. Let's bring these down. All right, amplitude, and we're going to ramp this up. And our distortion is climbing pretty quickly with this amplifier. I'm going to have to switch this into another range. This distortion residual is starting to clip, so give me just a second here. So as the output power rises, this amplifier has considerably more distortion than the stock design. We're already at 1% at only 12 watts. Let's continue to take this up. Yeah, so the distortion continues to rise here. And you can see our sine wave is becoming more of a triangle than a sine wave, and that's probably where that distortion is registering. We're getting more and more like a triangle as we go up. Just for kicks, I want to see if this hard clips at 35 or thereabouts. Yeah, we're seeing it flat top there. But yeah, the waveform is turning into a triangle and we're getting significant distortion. And I think this probably comes from the fact that this amplifier design does not use as much negative feedback. So you get a trade-off there. Let's take it up to where it comes to 1% and take a look at the different frequencies. So let's try 20 kilohertz here. It's staying there right around 1%. It's going on to 20 hertz. Yeah, this channel that was elevated before is all the way up at 2%. So the distortion performance is not as good. Let's check out the harmonic profile at the higher level. And that looks more similar to the other amplifier. So it's interesting, and that's not necessarily a bad thing. A lot of times people like the sound of a little bit more distortion. So it's going to be interesting to see how the listening tests play out on this one. But as far as output, I would say that this amplifier, what's going on here? Frequency. I would say that this amplifier really doesn't make it to 35 watts. I'm going to call it at wherever it meets 1% THD+N. Okay, we're now going to take a look at the frequency response of the amplifier. So again, I'm feeding in a sine wave from this oscillator to get us to 1 watt, and we're going to check and see what a square wave looks like first. So also very flat, and we don't have any of that high frequency ring. This has been rounded off, so there must be a filter on there that's helping with that. All right, let's do the same sweep and see what happens. So back to sine. And we're going to alter the frequency 1 kilohertz at a time. Oh, let me set the dB reference first. Maybe here, reference. Okay, here we go. We can see that it's already changing here. It's not by a lot, but it's not as consistent as the other one. The other amplifier went almost all the way to 20 kilohertz with no deviation. So at 20 kilohertz, we're down by about half a dB. Let's see where the negative 3 dB on this one is. Looks like it's going to end up about the same, somewhere around 55 kilohertz. Actually, it looks like it's going out a little bit further before negative 3. We're at about 64 kilohertz. Let me write that down. And then let's see what it does in the other direction. It's 100 hertz there. I'm going to wait for this to refresh. I think that might be stuck. There it goes. Yeah, it takes a while on these really low frequencies. So this one's also very flat. Let's see how far we can go down. It's 70 hertz, 60. 50. Let's give this a moment to catch up. Yeah, it's still going strong. Let's get down to, yeah, at 9 hertz it conked out a little bit. That's about where we tested the other one too. These are both pretty consistent in the low range. It's interesting, we have the same kind of phase shift at low frequency, a little bit of waveform deformation there as well. But in any case, surprisingly very good frequency response as well on this one. So the difference really seems to be in the output power level and the distortion characteristic. So it'll be very interesting to see if any of this translates to results in the listening test that steer everybody consistently in one way. All right, that does it for the bench testing. Let's get on to listening. Okay, so now on to the fun part, the listening tests. So the way that we handled this is when I showed up to the event that we had planned, so it was me and 4 other audio guys. When I showed up, I brought the amplifiers downstairs and covered them with the blanket before most of the guests had arrived. So they knew they were going to be listening to 2 different Dynaco Stereo 70s, but they didn't know what was different about them. So after we got to know each other a little bit, I sent all the guys upstairs and flipped a coin. The coin toss decided the original Stereo 70 was going to go first. So I set this up in the basement, covered it with a barrier so that nobody could see it, and then I fired it up, double-checked the bias, played a couple test tracks to make sure all the channel balance and everything was good and nothing was wonky, and then I called the guys back downstairs. Next up, I had each one of the attendees, so there was 4 guys, I had each one of them pick a track that they were very familiar with, and the idea was that we would each listen to the other person's track, but the person that picked it would get to sit in the sweet spot. So the tracks that we picked were Money for Nothing, Dire Straits, España by Emmanuel Chabrier by the Cincinnati Pops, Janis Joplin, Mercedes, and for some reason after that it auto-played Maggie May by Rod Stewart, so we left that one in, and then the last one was Sultans of Swing by Dire Straits. So 2 Dire Straits in there, but kind of drastically different songs, so it actually worked out well. Now for connecting a source, what we did is we took an iPhone with Tidal on it and we hooked it up with a Lightning to RCA cable and plugged it right into the front of the amplifiers. This eliminated any possible noise from power supplies and other stuff because it's a battery powered device, and it also eliminated all the variables of preamp coloration and stuff like that. So it was kind of a good way to do this test. The speakers that were used were my friend's set of Clements, and they were hooked up with a pair of Kimber TC8 speaker cables. After finishing the first round of tracks on the first amplifier, we had just a brief discussion about our impressions, and everyone agreed, but that's a nice amplifier, I wouldn't mind owning that, sounds pretty good to me. So that was the impression of amp number 1. I had the guys go back upstairs again. I took the tubes from this one, the 5AR4 and the EL34s, swapped them to the other amplifier, double-checked the bias, double-checked that everything was sounding proper, and then the guys came back down and we ran the whole set of tracks again. And it was instant. Basically the first notes that were played on Money for Nothing, everybody lit up and it's like, wow, I hear a difference. So that was amazing to hear, and it was unanimous. Everyone's like, this amp sounds drastically different than the first one. But we had to run through all of the tracks in order to make a full assessment of the differences between these 2 amplifiers, and I think the tracks that we chose really exposed this, so that's what I'll go into next. So after completing all the listening tests, 5 tracks on this amp, 5 tracks on this amp, we got together as a group and just had a debrief about everything that we heard, and the results were kind of surprising. So 2 of the 5 of us preferred the VTA amplifier on all tracks. Hands down, they said, this is a better amp, this is the one that I would buy. The other 3 of us were mixed. We liked the original on certain tracks and the VTA on other tracks. And next up, I'm going to be going into some of the individual comments that I heard during the debrief, and you'll get a better idea of what the difference between these 2 amplifiers is. So starting out with Money for Nothing, this was kind of our baseline. And like I said, when we first heard the VTA amplifier, I was like, whoa, that's a completely different amp than what we just listened to. And the big takeaway on the VTA on that track was it had better dynamic range. So on this one, Money for Nothing sounded great, but on some of the builds where there's big percussion, like build-ups and crescendos, the VTA seemed to have better control of the changes in dynamics. When we moved on to España, And that track was selected by one of our attendees that's a professional classically trained musician that performs in an orchestra daily. So he had picked a classical track just to get us all exposed to that. And it was interesting watching him go through it because he sat there and was conducting through it and kind of picking out different things. And it was an interesting experience to go through that and hear, okay, this is where that instrument is placed, this is where this instrument is placed. And the difference that came on these, I believe if I'm remembering correctly, is that the VTA had more pinpoint accuracy of placement in the image, where the original design sounded more natural and it was described as having more depth. So there, and on that one it was a mix. Certain of us liked España much better on the VTA, and others were like, no, it's got to be on the original one. So that's a genre thing. Maybe rock and roll is better on the VTA, and if you're a classical buff, you might be into this design some more. So that was kind of what we heard there. And another thing that we noticed is the triangle. So the percussion section of the orchestra really came out on the VTA. When the triangle started coming in, we could hear that clear as a bell. It was placed exactly where it was expected to be, and that was really nice. So the VTA seemed to be a little bit more precise on the placement of instrumentation, where the original design was kind of more pleasing to listen to in general with a little bit more depth, but maybe the sound stage wasn't as precise and separated. Moving on to Janis Joplin, this one was interesting. I'm the only one that had really specific comments on this one. And what it was to me, this is a track where it's just Janis Joplin singing, that's it. And it was a live recording, really raw, and it sounded to me pretty good on this amplifier, but when we listened to it on the VTA, it sounded shrill and too bright to me. And I was having a very hard time listening to that track. I almost stepped out of the room. So for me, the VTA was too piercing on that track, where it was a little bit more relaxed on the original amplifier. When Maggie May started to play on this one, we're just like, whoa, that's a cool song. Let's listen to it a little bit. It's like, oh yeah, that's a nice instrumental intro. But when we listened to it on the VTA, the harmonics and everything, it was just more detail in the instrumentation. So I think I preferred the VTA on that one. Most of the other guys did as well. And then finishing up with Sultans of Swing, one of the comments we got after listening to the first one was, there's something missing. And what we determined it to be was there wasn't any high-end, high-frequency sparkle. So when the guitar was strummed, you didn't get that kind of harmonic resonance that comes after it. So when we switched over to the VTA, the comment was, everything that I was missing in that track on this amp, the VTA did. So I noticed it when, again, the guitar was strummed. You just heard more of a harmonic body. I played guitar a lot in my youth, and there's just something, you can feel it when an electric guitar is just strummed and you have the resonance of the guitar, the neck, everything, and it just rings. That was more present in the VTA amplifier. And that was kind of it. So the conclusions were, these are both great amplifiers. One of the guys even said, if I didn't hear these side by side, I could have taken either of them home and been completely thrilled. So both very good designs, but they differ in the way that they reproduce audio. So there was a drastic difference in sound, but it was preferred differently by different listeners on different tracks, which is kind of consistent for audio listening. Everybody has their own taste. Everybody's ears are a little bit different. If you get a little bit older, you might lose some perception of high frequency. So an amplifier that gives you a little bit more sparkle might sound better to you than something that's more flat. So it all comes down to that. But overall, this was such a fun experience. I'm really glad that I did this and followed through with the listening tests. I'm more on the side of the bench tests, so it was great to get together with some other people with different opinions on this stuff and really listen to it. And I was surprised at how drastic of a difference there was between these two designs. Thank you so much for coming to the channel and checking out this video on the Dynaco Stereo 70s. I had such a good time making this video with the guys. And I'm sure a lot of you own either the original or the VTA, or maybe have experienced with both. So I'd love to hear from you in the comments. If you've heard something that I talked about today being consistent or inconsistent, what are your thoughts? What speakers do you like with the Stereo 70? Anything. I'd love to get a discussion going on these amplifiers. So thanks again for coming by the channel. If you like this content, I'd invite you to like and subscribe and come back for more content, and we'll catch you on the next one.